So in the last section, I mentioned a bit about the fact that my testing of this code wasn't really complete, and this is the exact example that I suggested. And you can believe whether or not I had looked at this this web page before giving that example. That'll be up to you to decide. But I claim I did not know that this was coming. Tangent aside, our stack implementation has an error when you pop on an empty stack, and it looks like this. You make your stack, you try to pop. Oh no, index error, pop from empty list. So this kind of sucks. We can probably look at some other ways to approach this. One option is to quote unquote fail silently. So in other words, you include documentation in your method to mention if the stack is empty, you do nothing. And so to avoid this error, you do if the stack is not empty, then you pop in everything. And if the stack is empty, then just nothing will happen, right? Because the client code in this case expects a value to be returned, it could use the fact that nothing was returned as a sign that something bad happened. But this doesn't work for everything, right? For example, push doesn't return anything, even when whether things go well or not. So failing silently doesn't tell the client that, hey, you tried to push something and this didn't work out, until potentially a ton of other things have happened after that point. In pop, which does return a value, if we treat none, like return nothing, which is what happens here in this code if you don't actually reach a line that says return some value. So none will get returned to them. If we treat that as indicating an error, we can never allow client code to push none to a stack. Like you may want to have a blank spot in your stack that just doesn't have something there. You now can no longer do this. There may be clients who want to be able to do that and recognize it as a value when it is popped off. And now you can no longer, if this is the implementation you go with, you can no longer distinguish between when is it actually supposed to be none there and when was there an error. An alternative is to raise an exception that you define as the user. So an arguably better solution is to give the client a clear signal, hey, there was a problem. We want these to be as descriptive as possible, but you don't really want to go into the implementation details. In Python, you can do this pretty easily. You define a type of error by making a subclass of the built-in class exception. So exception is a Python-recognized keyword that basically refers to errors that have come up. So here's how you can define your own kind of exception called empty stack error. You make a new class. It is empty stack error. It is a subclass of the superclass exception. And it is raised when you call pop on an empty stack. And we just say that's what it is. So we'll call this a user-defined exception. And here's how you use it in your pop method. So given you have this code here, you go to your pop method and you try to first, is it empty? If so, you raise your empty stack error and you say, hey, there's a problem. Otherwise, you just go and everything should be okay, hopefully. So this time when you do the same thing, make your stack, try to pop. Instead of getting index error, blah, 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 you now get empty stack error. When you want an empty stack error to happen, you construct an instance of the class and raise it. And the keyword here, raise, means specifically like stop the program, there was a problem that happened. We've seen this in the context of unimplemented methods in abstract superclasses from previous videos. Turns out that this is really flexible, especially in Python, and can be used anywhere in your code to raise exceptions, even ones that you've come up with. Note the line that is shown to the client is just the simple statement, raise empty stack error. Doesn't mention anything about details, like is there a list that's got size 0 or whatever. It just says empty stack error was the problem. So by defining your own errors, you can give whatever descriptive messages you want when they use your class incorrectly. Now, one limitation of what we've done is that simply the name of the error class is kind of unimpressive. Sometimes it's not really user-friendly. Like just seeing empty stack error, what does that mean? Maybe that's not enough. So you can override the string method in the class, the __str___ that belongs to all objects. We mentioned before that this is something that every class has because every Every class that you make is a subclass of object, and object has a string thing. So let's override it for our empty stack error. And instead, when we try to print out the empty stack error, we print out, you called pop on an empty stack, sad face. So this time, when you do the same thing, instead of just seeing empty stack error, you see empty stack error, colon, you called pop on an empty stack. The normal flow of control in a program involves pushing stack frames whenever a function is called. If I just go back to some of the stuff we did before, let's back up. Here we're in the middle of calling isEmpty for our stack. This is itself also a stack. This frame here and this frame here, this is a stack as well. Sadly, this visualization is not optimal because it's upside down. In particular, isEmpty was added on after the main function. So this thing here that says global frame, you can think of as like your main function. IsEmpty gets pushed on. We run through all the code, and when we're done with this method, it gets popped off. So normally the way that programs work is anytime you call a function, you push the stack frame on, and once you either reach a return or you reach the end of the code, you pop off that frame. When an exception is raised, something very different happens. Immediately, the function ends, its stack frame is popped, sending the exception back to the caller, which in turn ends immediately, sending the exception back to its caller, and so on until a thing is empty, in effect stopping the whole thing. At that point, an error message specifying the exception is printed, and everything is done. In fact, when this happens, much more information is printed. For every stack frame that is popped, there was a method or function that had been running and was at a particular line. The output you see when you are running Python shows you the line number and the line of code where this happened. So, here's an example of two useful methods and then a really silly one called messabout, whose sole purpose is exceptions. This is not the greatest resolution. Can I open this in a new tab? Okay, a little bit bigger. All right, where's the best place to start from this one? We'll just do it from top to bottom. Okay, we're importing a stack because we're lazy and don't want to copy all the stack code. We're going to have some new methods here. Clear stack takes a stack, removes all the items from it, and returns how much was removed. So go through the stack, keep popping things, and count how much was removed from it. Okay. Second from the top, return a reference to the item second from the top, and do not change the stack. Okay, so you pop and remember the top two things of the stack. And then push them back so that you leave the stack as it is. Presumably, if your stack works properly, if you pop item 1 and then pop item 2 and then push item 2 and push item 1, it should be back in the exact same order. Nothing should have changed. Fortunately, at this point, you now have a reference to that second object, so you can return it. Lastly, messabout, a pointless function that just demonstrates exceptions. We got names is a stack. We're going to push a bunch of names, clear the stack, then try to get the second from the top, then push Jacqueline, return the answer, and we'll see what happens. Now, let's resize this. Okay. Because messabout clears the stack, the second call, the call to second from the top is guaranteed to fail, no matter what, when it tries to pop even a single thing there. At the moment of failure, we're executing pop. And beneath it on the call stack are second from top, messabout, and the main block of the module, all on pause and waiting to finish. When pop raises the empty stack error, we see a full report of what's happening. So in our main method, which you can see line 44, in here it says module, but that's the main method. We go to messabout, and in, what is that, line 38 of messabout, that's over here, where we're doing second from the top. Second from the top, line 20, so that's over here. We're doing hold 1 is s.pop. Line 50 in pop. Well, that one we can't see here because that's in wherever we're grabbing the stack from, right? So the plus of this is this really, really helps you when you've made a mistake in your code, or when just something is wrong and you need to fix it. By being able to track where all the things are at the time of failure, you can pinpoint exactly where the mistake happens, especially in the cases of these specific errors, which also help you by telling you, hey, this is the kind of error that you've run into. You've probably seen this before, almost assuredly. I'd be surprised if you haven't. But it is a pure treasure trove of information to help you figure out what went wrong and where can you go to fix it. Now, your code can be written in a way that takes responsibility for quote-unquote catching and handling exceptions. Catching an exception and taking appropriate action instead of allowing the whole thing to crash is way better than just, running into the first error and saying, oh, my whole program fails. It's not really great. It shields users as well from seeing errors that they should never see and allows programs to continue in cases where you can deal with the fact that a mistake has been made. Although we'll go through a few examples of catching and handling exceptions, you should read the documentation on exceptions just to see how they work, particularly how to handle an exception and what is a cleanup action. So, simple example of this. Ask for user for an input as an integer number. Test if it's a divisor of 42. Now, this means you need to make sure that you're getting good input. So first off, is your input a number? Is it actually an integer? And also, is it going to cause, for example, a division by 0? That's probably a bad thing. So here is a way that you can do this gracefully. In our function, we have option y. While that is the case, we get the input, give an integer to see if it's divisor of 42, and we try to see if that works. So is divisor is our result for 42 modulo the integer of that value, and is it evenly divisible, meaning modulo result giving us equal to 0. And we print that happening. Some things could go wrong in here. First off, we could get a 0 division error. This is, 0 can't be a divisor of a number. You shouldn't divide by 0 so that you don't break everything in the universe. This is an error that could come up. So we have try here with a colon, and to indicate this is the area where we think something bad could happen. And if this specific error happens in that block, we quote unquote accept it with not with an ACC but an EXC, and then print this message, which then won't cause the whole thing to crash. We can actually continue onward. We also might see a value error. For instance, you put in the letter A, but we were actually expecting a number, in which case you get value error, and so we tell them, hey, this is the wrong type, please give us an integer. If one of these errors happens, we probably should try another number. And so then we prompt, do they want to continue, yes or no? If they put yes, we keep going, no, we terminate. In the context of our stack, we can similarly handle an empty stack error gracefully. So gracefully, basically in all forms of computer science, pretty much just means when something goes wrong, don't just crash the whole thing, because it's not really great. Now, for our stack, we don't necessarily have to print a message to the user, although we can do so, but you should document this specific circumstance in the doc string and change the return type from just always return string to optionally return string. So in our second from the top, we might run into a problem when we're trying to, grab from a stack where it doesn't have a second from the top. So we try to do everything that we were trying to do from our second from the top method. And if we run into an empty stack error, which could happen if we're trying to pop and there isn't enough to pop there, we accept it and we print out can't return second from the top because the stack is empty. And in this case, we always are going to return something. However, whether we're actually returning what's in the stack or returning none depends basically on did this code actually manage to go through without a problem.